Okay, today we're going to be talking about graphing sine and cosine curves. We're going to start where our goals for today is that we understand the difference between a sine function and a cosine function, how to graph it. And then we can look at an equation and we can identify the amplitude, the period, the phase shift, the vertical shift, and so on. So let's look. We're going to start with just, okay, remind ourselves, what is the basic shape? The basic shape of a sine curve is the curve here. I kind of ran out of space here. You start at 0 and it ends at 0. For a cosine curve, it starts up at the highest point and ends back at the highest point. And so this is our highest point, our lowest point, our midline is right here. Usually it's at 0, 1, and -1. Here, same thing here, 0, -1, and 1. But it just depends on the curve and the equation that often changes. So let's talk about amplitude. First of all, the amplitude is shown by the value in front of the word sine or the words cosine. And what the amplitude does is it kind of stretches our line here. It stretches it higher or lower, all right? So the amplitude is really the distance between the midline and the bottom value here. And the amplitude is really just the sign here, the number in front of the word sine. If you ever do have a negative, like say y equals a -3 sine, the negative is not part of the amplitude. The negative is actually telling you to switch it around. And so that answer, that one would actually kind of look like this is how it would look. All right, so that's our amplitude. Next thing we're talking about is a vertical shift. So a vertical shift, you actually would start here, and a vertical shift like that +4 would actually move it 4 units higher. So a vertical shift could be higher, a vertical shift could be lower. Amplitude is an absolute value, so it could only be positive, but here vertical shift can be a positive or a negative. Next one is phase shift. So this one would actually be a phase shift of 30 degrees negative direction. So where our original is right here, the phase shift of a -30 would be right there. To find the phase shift, I'm going to be saying a lot. We're going to take what's in the parentheses and set it equal to 0. So in other words, x plus 30, when that equals 0, what would x have to be? X would have to be a -30. And so that had a phase shift of a -30 degrees. We also have phase shifts in radians shown to us sometimes. Now, period, I think this is one of the most difficult concepts, is this idea of a period. A period is the time or the length it takes to do one complete rotation, okay, kind of thing. So here in the blue, our period here is our usual. If it's degrees, it's 360 degrees. If it's in radians, it's 2 pi radians, all right, to do a complete cycle is what I was looking at. Where now, this one here in red is saying now I want 2 cycles in the usual space where there's 1. So it would be the same amplitude, but now we have 2 cycles. So this one, the period actually would be 180 degrees or pi if it was in radians. So the period is the time it takes you to do one of the cycles, okay? So the period is the time it takes you to do one of the cycles. The period, we usually say it's either 360 if we're in degrees divided by that k. K is always the coefficient of our variable. If we're in radians, the period is going to be 2 pi divided by our k. And you're going to see that over and over again. So let's look at this. We're going to move on from that. Let's look at some examples. And this is actually from the worksheet that you were given, number 2. So number 1 and 2, or actually number 3. 1 and 2 just talks about what does a sine curve look like? What does this cosine curve look like? This is number 3. All right. So here our amplitude is 3. Now, we could show a really high amplitude and a really low amplitude. Thing is, we never have time, or not time, we never have the space to do that. Like on our worksheet, that'd be really difficult to do. So what we do is we show a typical sine curve, and then we show the amplitude by saying, okay, the highest point here is 3. We start at 0. The lowest point would be -3. And so we show that amplitude simply by having the values shown here. So that amplitude is shown with our y values, excuse me. And so we kind of mark it that way. Then if we have a negative like this one, we still have an amplitude of 2, remember? And this one actually would be a positive 2. Amplitude is always positive. And so the highest it could go is still 2. The lowest it could go is still -2. What's changed here is that it's going to go down and then up instead of up and then down. So it's kind of like had a vertical flip, if you will. It's kind of been having an inverse of it done here. So basically our curve is flipped around. All right, next one. Now we're looking at a vertical shift. So now this one has a vertical shift of +5. Now again, we could say, okay, instead of starting here, we're starting down at 1, 2, 3, 4, 5, and say we start here, and we could have our. That's hard to do. It's hard to do that. It's hard to have the space on all of them. So let me show you what we actually do. We actually put it here. I'm going to go ahead and erase that. What we usually do, and we just have found in the past has been helpful, is we show the vertical shift is our midline. And so we make that our new midline. All right, so that's our new midline. And then here our amplitude would be 1. So from our midline, it's going up 1 and down 1. And so actually I had the wrong curve before it. This would be my answer here because it's a cosine curve. So the highest point was 6, the lowest point was 4, but the midline was 5. So our vertical shift is really our midline, and we're going to have to get used to that. All right, let's look at another one. Now our vertical shift was a -3. So now our -3 is our vertical shift. +1 would be -2, and lower than that would be -4. So this curve looks like that, all right? And it's really just about, okay, do I have the right midline here? Next is our, we're working here with our period. So for this one, our period, and we're in degrees, it says that in the directions, our period would equal 360 degrees divided by our k, divided by 6. Because what happens is they're saying 6 of these would happen in the space that there's usually usually one curve. So where we usually have one curve, and I'll show you here, this is usually a sine curve, we actually want 6. So we have to go 1, 2, 3. Oh, I didn't even do it. 4, 5, 6. Oh, it's hard. It's hard to get them all in there. I didn't start off close enough. Let me see if I can get rid of that and try again. Let's do this over here. I got to try again. That was not good at all. Let's try this again. I didn't pace it at all. It's not easy though. Let's try. 1, 2, 3, 4, 5, 6. I might have 7 of them. All right. See, this isn't easy. And really, we're only going to be ever dealing with is 1, which would be right about there, 1 curve. So what we do, the way that we write this out, all right, kind of ingenious, we get a little smarter than this, is we say to ourselves, okay, I just want to show 1 curve. But I know this is just a part of it. I know that's just like the first part of it. So instead of being at 360 degrees here for a complete rotation, I have 6 in there. So this one would be at 60 degrees. Halfway here would be 30 degrees. Half of that is 15 degrees, and this is 45 degrees. So that's the way to show that, hey, my period, I have a complete rotation here, a complete cycle in that 60 degrees. And that's what I'm looking at, is where is that cycle. So I kind of changed my window, if you will. So if you've ever had a graphing calculator and we kind of change the window, all right? So really what we know is really this curve looks like this. All right, but I said I'm going to change the window that I'm really just going to look at it this part. All right, so even though I might look up, down, that's what I'm looking at. And that's really what I have here, just so it's easier to see as I kind of show my window. I'm showing it in a different way. Okay, now here for this one, now we're in radians. So the big deal here is we changed it from degrees to radians. So now my period is going to not equal 360 degrees, but 2 pi radians divided by 4. 2 pi radians, is pi over 2 radians when I reduce it. So again, I'm dealing with my sine curve, but here, instead of being at 2 pi, it's going to be at pi over 2, which is kind of like our 90 degrees. Halfway would be pi over 4th. 1/4 is half of a half. Half of a 4th would be pi over 8, 1/8. Here, this would be 3 pi over 8. And we're going to be seeing that again and again and again. So now, we're going to be dealing with a phase shift. Now, phase shift is the one that I don't usually change my I show the original and then I show the phase shift. I've just found that that's easier. So my original here, I'm going to do it in dashed, is that this is at 360 degrees. This is at 180 degrees. This halfway is 90 degrees. This halfway is 270. So there's my quadrants. Now, same thing, same curve here. I need to shift it, and it has a phase shift of a negative 30. Now, if you remember, for the phase shift, we take what's in the parenthesis, set it equal to 0, and then solve it. So, yep, my phase shift would be a negative 30. So what I need to do here is I need to move that negative 30. So now what this point is going to be is at negative 30 degrees, not at 0. At this point, I'm 30 below this, so I'm 30 below 180. This is at 150 degrees, not 180. This point where it ends is at 330 degrees, not 360. The halfway point would be at 240 degrees, not 270. This halfway point would be at 60 degrees, not at 90. So I kind of just shifted everything and subtracted 30 from everything to find my new points. It is going to be important to list these quadrants, which is 5 points. It kind of cuts everything into 4 parts here. Okay? We'll see that more when we get to examples. This one, and I don't have the right one. I have to kind of fix this a little bit. On number 10 in your packet, and I kind of have the wrong thing here, and I apologize. I had x minus pi here, and now I was in radians. So I want that in radians. I might have it on the next slide for all I know. Okay, so now my phase shift is positive pi. Okay, so usually if I was in radians, this would be pi, this, or 2 pi, excuse me, this would be pi. This is pi over 2, my 90. This is 3 pi over 4, which is 270. Now I'm going to shift it. Now I'm shifting this to the right. All right, so I'm shifting a positive pi. Oh, look, there goes a whole pi that I'm shifting over. So the new ending point would be 3 pi there. This halfway point, 3, 4, 5 pi over 4. Okay, so everything kind of shifted to the right. Remember, usually it's going to be the opposite value of what you have in your original problem. Yep, I was right. I should have just been patient. All right, so that was number 10. Let's look. I'm gonna go ahead and pause this, and we're gonna have another video that has some examples in it. So I'm gonna go ahead and look for video 2 for the example.